In this section, we're looking at dilations and scale factor. So in the first activity, we're going to determine the scale factor of a particular image. So we're going from our regular old triangle, in this case, to another triangle, which we call the image of the triangle. So this right here, this triangle ABC is our pre-image, and that's what we call our image. So we're starting at ABC, we're getting to A prime, B prime, C prime. So in this particular one, we want to find the ratio of AD to A prime D. We don't want to measure it using a ruler. We just want to see if there's any kind of a relationship between the corresponding pieces. So point D is our dilation point, and that's where this original triangle ABC is being dilated from point D to be our new triangle A prime, B prime, C prime. So the corresponding parts are, you notice A and A prime are both on that same dilation line. So we're looking to see, is there a relationship between those points? So if I look at my coordinates of A, I notice that my coordinates there are 1, 2. If I look at my coordinates of A prime, it's 2, 4. Looking at the x's and looking at the y's, each of those seems to have doubled to get to our new image point. So if I'm finding the ratio of AD to A prime D, my ratio would be 2 to 1. Same with BD. If we look at the point there, we have 4, 2, and B prime is at 8, 4. So again, I took my x coordinate, my y coordinate, doubled them to get my image point. So BD to BD, or B prime D, I'm sorry, I've got this backwards. AD to A prime D should be 1 to 2, and same here, 1 to 2 for BD to B prime D. And CD to C prime D, so C is at 3, 3, and C prime is at 6, 6. So 3 to 6, 3 to 6, we're doubling there. So again, CD is 1 to 2. So now the ratio of the triangle, we want to calculate that and write our answer in the form x colon y. So again, just a ratio like these other ones here. Any corresponding part from the image triangle, the pre-image triangle to the image triangle is going to be in that ratio of 1 to 2. So when we find the ratio of the sides of the triangle, it's going to be the same thing. Now notice that when we increase the size of triangle ABC to get A prime, B prime, C, we didn't change the shape, we just changed what the size of the shape was. So in other words, all of our angles here are still preserved. We're just changing how long the sides are. Based upon our answers, solve the equation kx equals y for k. I'm going to show you how to do this real quick, and then we're going to kind of reason our way through it. But if we have x, let's say x and a 1, so we have k and then equals 2. That is our scale factor. But let's just think about this. What happened to our triangle? If we had triangle ABC to get this triangle A prime, B prime, C prime, we clearly made it bigger by a factor of 2. We multiplied every single side by, or every coordinate by 2 to get that new triangle. So our scale factor would be 2. Now again, you can solve it by the equation or reason your way through it that, well, the sides are doubling, so the coordinates are doubling, so it's a scale factor of 2. Similarly, number 2, following a dilation about point E, ABCD becomes A prime, B prime, C prime, D prime. Find the ratio of AE to A prime E. So AE, we're looking at point A, which is at negative 2, 1. And we're looking at point A prime, which is at negative 1, 1 half. It appears that what's happening here is that the side, or the points, are being cut in half to get my image point from my pre-image. And that works for any of the points that we use. So if we looked at B, B is at negative 1, 3. And if we cut that in half, we would get negative 1 half, negative 3 halves, which is exactly where point B prime is located. So the ratio of AE, which is our original image, to A prime E, which is our smaller piece, is 1 to 2. I'm sorry, 2 to 1. I got that backwards. I'm sorry. 2 to 1. So again, we're just cutting that in half. And again, we can verify that it does work for all the others, and it will. So if we take each of those points from D and cut them in half, apply the ratio of 2 to 1, then it will get us down to that. So the ratio of the pre-image to our image is also 2 to 1. For scale factor, again, what are we doing to the shape? Well, it looks like we're taking this quadrilateral and we're making it smaller. We're applying that multiplication of 1/2. So our scale factor would be 1 over 2. All right, we'll do this last one here, and then we'll talk about how do we actually go ahead and create the image from the pre-image, knowing the scale factor. So kind of the reverse of what we're doing. Find the ratio of AD to A prime D. So if we look at A, which is at 3, -3, and A prime, which is at 2, -2, I want to figure out what happened to get there. And this one's a little bit trickier to do, but let's think about the point 0, 0. And in the x direction and the y direction, A is 3 away. For A prime, in the x direction and the y direction, A prime is 2 away from the dilation point. So our ratio then would be 3 to 2. There's 3 like pieces for every 2. Let's just make sure that works for B. If we look at B in the x-coordinate, we're going to focus in on that one. This is an x-coordinate of 6 and an x-coordinate of 4 for our image. Well, if we took 6 compared to 4 and we reduced that, we would get the same exact thing as we got up here, which is 3 over 2. So the scale factor of that, again, is kind of the reverse of the ratio of the sides of the pre-image to the image. It would be 2 to 3, 2/3. So triangle A prime, B prime, C prime, we expect to be 2/3 the size of the original triangle ABC. Now in activity 2, we're going to do the same type of thing except go backwards. And what I've done is I've already drawn in the dilation lines because it makes this go a little bit quicker if we do that. Triangle ABC is dilated about point D with a scale factor of 2. To create triangle A prime, B prime, C prime, draw the triangle on the coordinate plane below. So when we have a dilation, the pre-image and the image should fall on those lines of those dilation lines. So we're going from the dilation point through each of the vertices. Now what's going to happen is by applying a scale factor of 2, we're going to take our coordinates and we're going to double them. But the reality is we don't need to actually multiply all of it by 2. We can pick a convenient point that will work. And for 2, it's not a big deal. We can easily double things. But when we get into fractions, not always going to be easy. So let's take a look at a scale factor of 2. Let's start with point C because it's just right there. If we have a point at 2, -1, if we double 2, which is our x-coordinate, we'll be at 4. So if I go to 4 and follow that down till I hit the dilation line, there's where C prime is going to be located. And again, if I wanted to verify, I could take my y-coordinate and double it, and I get -2, so it works. I'm going to do the same thing for A. So I'm at -1, -2. So if I double my x-coordinate, which is -1, I go to -2 and I follow it down, and there's my image. Do the same thing for B. So I'm going to pick x equals 1. That just seems like the easiest thing to do. We go to 2 then, and follow that up. And there we are, B prime. So then we can take those points, we can connect them, and that would give us our triangle, which is now an image of the original pre-image. So let me try and do my best to draw my straight lines here with my compass on my computer screen. All right, that one worked. And then we can connect B and C. Oops. And then connect A prime and B prime. And then so that larger triangle, that is our image, and that smaller triangle that we had was our pre-image. Again, our image is bigger than our pre-image because we've had applied a scale factor of 2. Let's look at a more challenging one. Let's do number 3 here. We got a scale factor of 1/4. We're going to use that to create our image. So again, I'm going to look at my points, look for some nice convenient points. In this case, I'm going to start with point B because that's the easiest one to work with. If I have a point at 4, 4, and apply a scale factor of 1/4, so I can take 1/4 of my x-coordinates, so that would be 1, and find where that's on the line, so it's right there. So there's my B prime. I think the next thing I'm going to do is point C. And for point C, I've got an x-coordinate of 6 and a y-coordinate of 1. I don't want to deal with that 1 because I'm not really sure where 1/4 is supposed to go on the grid. I have an idea, but it's not going to be very accurate. So let's go with 6. If I take 1/4 of 6, that's 1.5. So that gives me an area somewhere right in here for C. So that's C prime. And do the same thing for A, but this time I'm going to use the y-coordinate. So the y-coordinate is -2. I'm going to take 1/4 of that, so that's -1/2. So I'm looking for where y is -1/2, and that's somewhere around there. So that's going to be A prime. And now once I have those points, I can connect them. And that gives me my image. Again, that triangle does look significantly smaller than our pre-image triangle, and that's exactly what happened. We have 1/4 the size of that triangle. So again, once you got those dilation lines drawn in, it's pretty easy to just use that scale factor, pick a convenient coordinate, and find where that is on the line. And that will give you both of your coordinates.